Hello guys, welcome back once again to my YouTube channel. So in today's video we have this question that if a raised to the power x plus bx is equal to c, make x the subject. Okay, so this is the question that we have, and we have to make x the subject from this equation right here. Okay, so we are going to solve this question using Lambert function. I've already explained the concept of the Lambert function in my previous video, so we are going to use that knowledge to make x the subject from this equation. And if you're able to find the solution to this problem, then you can solve any equation in this form using that same procedure. All right, okay, so solution. So this is what we are going to do. We are going to move this bx to this side. A power x will then be equal to c minus bx. Then we find ways and means to make this power here the same thing as this one. I mean, we have to manipulate this power here to get something like this as the power. Okay, so looking at this side, the x is attached with minus b, but this x here is it's just x, so we have to find a way to make this exponent also a negative b, right? Okay, so this is what we are going to do. Because there is no b here, we are introducing our own minus b, so something like this. But if you have to leave it like this, it changes this whole thing. I mean, this is not the same thing as this, so this is what we are going to do. Then we raise it to the power of negative 1 over b, so that if you have to simplify this whole thing again, this minus b will cancel out this minus b, then we will be left with only a power x. Okay, so this will be equal to c minus bx. Okay, now we are left with the c. We've got 10 power minus bx, it's left with the c over here. So what do you think we should do? Okay, so this is what we're going to do. We have to multiply both sides by a raised to the power c over minus b. Now the reason why we are doing so is that because of this power minus 1 over b, let's just write that one. So we multiply both sides by a raised to the power minus c over b, so we get something like this, equals same expression multiplying c minus bx. Okay, now we know a raised to the power minus c over b is the same thing as a power c or raised to the power minus 1 over b. Okay, so this expression at the left hand side can be also written as a raised to the power c minus 1 over b multiplying a raised to the power minus bx raised to the power minus 1 over b equals this same expression over here, right? Now because they are sharing this same power, we can rewrite this whole thing as a power c multiplying a raised to the power minus bx raised to the power minus 1 over b. Like if you have something like this, let's say 3 power 2 times, let's say 2 power 2. So that's the same thing we've applied over here. It's equal to the same thing. Okay, so e raised to the power c multiplying e raised to the power minus bx, same b's multiplying, so we have to add the exponents. So we get a raised to the power c minus bx raised to the power minus 1 over b equals a raised to the power minus c over b multiplying c minus bx, right? Okay, so from here we can decide to multiply this one through by, so we get minus 1 over b multiplying c minus bx equals a raised to the power minus c over b multiplying c minus bx. Okay, so if you can clearly remember in my previous video, I made an illustration that x is equal to this, the same thing as this one, right? So this whole thing can also be the same thing as e raised to the power the natural log of the whole of this term over here. So this minus 1 over b multiplying c minus bx, and it's equal to a raised to the power minus c over b, right? Okay, now from the properties of logarithms, this whole exponent right here can be transferred to this side, so we get minus 1 over b multiplying c minus bx. Oh, okay, let me write it again. So we get e raised to the power minus 1 over b multiplying c minus bx, then multiply the natural log of a, equals a raised to the power minus c over b multiplying c minus bx. Okay, now this is what we are going to do next. We are going to divide through by this whole thing, c minus bx, natural log of a, same thing here. Okay, so this whole thing cancels out this. Okay, now this denominator that we have over here is the same thing as 1 over the whole of this, right? So because of this negative sign, if we are to transfer this whole term to this side, the negative will disappear. I mean, if you have something like a 1 over a power n, it's the same thing as a power minus n, and in that same way, if you have 1 over a power minus n, it's the same thing as a power n. Okay, so we have 1 equals a raised to the power minus c over b multiplying c minus bx, then multiplying e raised to the power 1 over b c minus bx ln of a. Okay, now divide through by this term here. I mean, we want to get rid of anything that does not involve x, so we get minus c over b minus c over b, so they cancel out, right? Okay, the same thing applies to this one. If you have to transfer this thing to this side, the negative will disappear, so we get e raised to the power c over b equals c minus bx e raised to the power 1 over b c minus bx ln of a. Okay, so if you remember our principle, we should get it in this form. So we should try and get this whole term at the right hand side in this form. Okay, so if you check these two terms, you can see the only difference between them is the 1 over b and then the natural log of a, right? So we have to introduce a 1 over b multiplying the natural log of a to this term. So that means you have to multiply both sides by 1 over b ln of a. Okay, so if you have to multiply it to this side, we get the whole of this multiplying e raised to the power c over b equals multiplying it to this side also, you have 1 over b c minus bx ln of a, then multiplying e raised to the power 1 over b c minus bx ln of a. Okay, so the same thing. So this is the same thing as this. So with that being done, we can take the product log on both sides. Okay, take the product log on both sides, and then this whole thing reduces to only this one. So we get 1 over b c minus bx ln of a equals product log of a raised to the power c over b multiply 1 over b ln of a. So let's see. Okay, so from here it's just some basic math. Making x the subject from here, it's nothing difficult. So multiply through by b. We can multiply both sides by b so that this b cancel out. Okay, so we are left with c minus bx ln of a equals, we have w c over b 1 over b ln of a multiplying b. Okay, you can divide through by natural log of a also, so we get c minus bx equals, so we can write this as b over natural log of a multiplying w of a raised to the power c over b 1 over b natural log of a. Okay, so we can bring this to this side, the bx to this side, and then send this whole thing to the other side. So we have bx equals c minus b over ln of a multiplying product log of a over c a raised to the power c over b and multiplying this whole thing. So just divide through by b, or multiply both sides by 1 over b. Okay, so x would then be equal to, okay, so it's the whole of this multiplying the 1 over b. Okay, so we have 1 over b multiplying c minus b over ln of a c over b 1 over b ln of a. So this will be our final answer. Okay, so if you're able to understand it up to this point, you can solve any equation in this form. Like let's say if you have, let's say 3 power x plus 2x equals, let's say 5, right? Okay, so looking at this equation, you can just say that x is equal to 1 because 3 raised to the power 1 is 3 plus 2 times 1 is 2, 2 plus 3 is 5, so x is equal to 1. But if you are asked to solve it, because you've already found a general solution for this, this is a general solution for any equation in this form. If you are to compare, a is equal to 3, b is equal to 2, and then c is equal to 5, so we just have to put in the values to this one and then you get your final answer. But if you have to solve this problem in general, you have to go through all of the steps. You can't just quote this final thing and then give it as an answer. No, it's not acceptable. So what I'm trying to say is that you can use this one to verify, to check for the answer, to know if that's it. Okay, so thank you for watching, and I'll upload one more video on the Lambert function, solving some examples so that we get familiar with the procedures. Okay, so thank you for watching, and I'll see you in my next video. Goodbye.